Okay, so in this video, we're going to talk about all the methods to solve quadratics that we've covered. So the first one that we did was factoring, and we had different methods for factoring. I'm only going to cover one in this particular video, but there are multiple ways to factor and solve a quadratic, but I'm just going to cover a trinomial quadratic. We have the square root property. We did completing the square, and most recently, we did quadratic formula. Okay, there are many ways. So the first two you can use only in specific scenarios. So if it factors, it factors. If it doesn't, then you can't factor it. Square root property only works if you have a square term only. So if you have that binomial that's not squared out, or an x squared term with no x term, completing the square and quadratic formula will work every single solitary time, no matter what. Unfortunately, in this class and in college algebra, you have to solve by all methods appropriately. So you don't get to just choose. So if you chose quadratic formula, would it work on every single problem every single time? Absolutely, 100%. The problem is you have to be assessed on each method. And that is not just for my class, but that goes for college algebra and beyond. Okay, so we're going to cover an example of each of these. Okay, so to solve by factoring in this particular problem, we do our two binomials. We have an x and an x, and we are looking for the factors of 15 that are negative 15 that will add to give me a negative 2. So what you are doing here is, if you make a factor tree, this is not a prime factorization. We're just talking about the factors of 15. You have 1 and 15. And 3 and 5. So we already know these sets of things are multiplied to be 15, but what we're looking at to get our negative 2 is a combination of the two things highlighted. So is the difference in 15 and 1 a negative 2? Of course it's not. But is the difference in 5 and 3, could that be a negative 2? Yes, so we put our 3 and our 5, and then we have to decide on our signs. So if I want a negative 2, then my greater number is going to have to be negative. So a negative 5 plus 3 is going to give me that negative 2 in the center. So once I've factored, I take my factors and set them equal to 0 and solve. So I have x is equal to negative 3 and x is equal to 5. And we can put those in set notation, so negative 3, 5. Okay. So the next method that we talked about was the square root method. So the first thing that we have to do is isolate the square term. So in this particular problem, it's not just an x squared, it's this binomial squared. So I have to get it on a side by itself. So the first thing I need to do is subtract 2. So I have x plus 3 quantity squared is equal to negative 12. I immediately know at this point right here, because of this, I'm going to have what type of solution? Imaginary, because when I have a square set equal to a negative number, I know I'm eventually going to take the square roots of both sides, and that is the very definition of an imaginary number. So to continue to solve, I'm going to square root both sides. So I have x plus 3 is equal to plus or minus the square root of negative 12. So I'm going to subtract 3 on both sides to isolate x. So I have negative 3 plus or minus the square root of negative 12. Okay, so am I done? No. I know I have to take the I out. So I have x is equal to negative 3 plus or minus I square root of 12. Now is it done? No, we have to ask ourselves, is 12 a perfect square? No, it's not a perfect square. But does 12 contain a perfect square? The answer to that is yes. So I have negative 3 plus or minus I square root of 4 times 3. So I have x is equal to negative 3 plus or minus 2I square root of 3. So I have two solutions because it's a quadratic, and they are both imaginary. The next method is solve by completing the square. So we know that the first thing we have to do is get the constant on the other side. So I'm going to subtract 3 from both sides. I get x squared minus 8x, a blank to complete my square, -3, and a blank to balance my equation. So if I had a coefficient here, I know that I would have to divide that coefficient out as a GCF before I continued. This one just does not have that. So how do we get what goes in the completing the square blank? So we're going to take half of the center term and square it. So half of -8 is -4, and -4 squared is +16. I don't have anything multiplying by the 16, so to keep my equation balanced, I'm just going to have to add 16 to the other side. So now that I've completed my perfect square, I'm going to write it as a perfect square. And that binomial is -4. It's always that half of the center term is equal to 16 minus 3 is 13. So at this point, we have a square root property problem, and we solve it the exact same way. So I have x minus 4 is equal to plus or minus the square root of 13. I had 4. So I have x is equal to 4 plus or minus the square root of 13. So then the question becomes, am I done? Yes, 13 is not a perfect square, nor does it contain a perfect square, so I have nothing left to simplify. Okay, last we have the quadratic formula. So remember, this one is set up for us, but remember quadratic formula has to be set equal to 0. Then you identify your parts. So I have that A is 6, B is 2, and C is a +1. So then my formula, x is equal to the opposite of b plus or minus the square root b squared minus 4ac all over 2a. Then it's just a matter of plugging into that formula. So I have x is equal to the opposite of 2 plus or minus the square root of 2 squared minus 4 times 6 times 1 all over 2 times 6. Okay, so I have x is equal to -2 plus or minus the square root. Now I would plug this in my calculator as one long stream, so 2 squared minus a parenthesis, 4 times 6 times 1. You don't have to put the times 1, but just as a measure of habit. And that gives me a -20 all over 2 times 6 is 12. So we have several things to take care of. We have the negative under the root that we need to deal with, and we also need to determine whether we can or cannot simplify the square root of 20. So I have x is equal to -2 plus or minus. To get the negative out, I have that I over 12. Does 20 contain a perfect square? Yeah, 4 times 5. So I have x is equal to -2 plus or minus 2i square roots of 5 over 12. So then the question becomes, am I done? No, remember that our imaginary solutions have to be written in the a plus bi form. That is non-negotiable, so we need to break this apart and then simplify. So I have -2 over 12 plus or minus 2 over 12 I square root of 5. And we have x is equal to -1 over 6 plus or minus the square root of 5 over 6i. So we can put that I last in that fraction. Just make sure that it doesn't look like it's under the square root. And that would be our final answer.